In this video, I'm going to show you how to formulate a dynamical system. Here is an example. Before you even attempt to formulate a dynamical system, it is important to first try to understand the scenario. So if you understand the scenario, it is much easier to formulate a dynamical system if you really understand the scenario. Okay, let me start by reading the scenario. Then we'll go ahead and answer the questions. Your grandparents have an annuity. The value of the annuity increases each month by an automatic deposit of 1% interest on the previous month's balance. Your grandparents withdraw 1,000 at the beginning of each month for living expenses. Currently, they have $50,000 in the annuity. Model the annuity with a dynamical system. Will the annuity run out of money? Yes, but I'm not sure when. At this point, I'm not sure when. Yeah, the following question is when. I'm not sure when. We are going to calculate that. Hint: what value will an annuity have when the annuity is depleted? Okay, first step here, we have to identify the initial value. The initial value is the value that we start with. Currently, they have 50,000 in the annuity. So 50,000 is the initial value. So first step here, I'm going to write A sub 0, which is equals to $50,000. This is our initial value. So initial value is the value that we start with. So we start the scenario by this value. Okay, by this value. So this one is the first step. Okay, we identified the initial value. Here is our second step. This is change. A sub n. This is change. Change is equal to some function. Okay, the value that we have right now in the annuity is $50,000. The value that we have right now is $50,000, but there will be some changes that will occur to this month. Here we are told that the value of this annuity increased by 1% interest. Increased by 1% interest each month. So that's a change. So change is equal to some function. So now let's formulate a function out of this scenario. Let's take interest and divide it by 100. Interest 1 divided by 100. Answer is equal to 0.01. 0.01. Then here I'm going to write 0.01. Then I'm going to write A sub n. A sub n. Your grandparents withdraw 1,000 at the beginning of each month for living expenses. So it's yes, we're going to have minus. I'm just going to ignore the dollar sign. I'm just going to write 1,000 and minus 1,000. So change is equals to some function. So change is equals to some function. And function and change is the same thing as change. Let me write change here. Change is the same thing as a sub n plus 1, a sub n plus 1 minus by a sub n by a sub n. So I'm going to replace change by this thing. So I won't write change anymore, I'll just write a sub n plus 1 minus by a sub n minus by a sub n, which is equals to this function that we have here, which is 0, 0,01 a sub n minus by 1000. Okay, this is our third step. So now we have to make a sub n plus 1 the subject of the formula. So here I'm going to write a sub n plus 1 is equals to, and here I'm just going to transpose. The sign of a sub n is going to change, it's going to be positive. So it's a sub n plus the interest a sub n minus by 1000. So this one is the final answer. This one, initial value in this equation is the dynamical system. We can go ahead and add these two because these are like terms. Let's just do so. A sub n plus 1, a sub n plus 1 is equals to, here we're just going to add. So we're going to have 1,01, then close the bracket, then is a sub n minus 1000. So now we formulated the dynamical system. Then now let's answer this question. Will the annuity run out of money? Yes. When? We have to calculate that.